40 seconds. That is all the time that separated two major earthquakes in northern Venezuela on Wednesday night. A magnitude 7.2 followed almost instantly by a magnitude 7.5. Both were shallow. Both hit less than 150 kilometers from Caracas, and both earned a red alert, the highest impact tier the United States Geological Survey issues. But it is what the sun was doing at that exact moment that turned a disaster into a mystery. By the end of this video, you will know exactly where the real danger lies now. On Wednesday night, the ground beneath northern Venezuela did something that earthquakes almost never do. It broke twice. At 6:04 in the evening, local time, a magnitude 7.2 earthquake tore through the crust near the town of Umare, in the densely populated zone where the states of Yaracuy and Carabobo meet. Roughly 40 seconds later, before the first shock had even finished radiating outward, a second and larger rupture, a magnitude of 7.5, ripped across a neighboring stretch of the same fault. Two major earthquakes back to back, separated by less than a single minute. That is not how this usually works. A large earthquake is normally a single event, followed by a long tail of smaller aftershocks that fade over hours and days. What happened in Venezuela is something seismologists call a doublet, two near-equal major earthquakes hitting essentially on top of each other. And when those two ruptures are a 7.2 and a 7.5, less than a minute apart, you're looking at one of the most violent single moments of seismic energy release the planet has produced in years. Both quakes were shallow, centered only about 10 kilometers below the surface. That depth matters more than almost any other number in this story, because a shallow earthquake delivers far more of its energy to the surface than one that is buried far below. The shaking does not have hundreds of kilometers of rock to travel through and weaken. It arrives at the cities above almost undiluted, and these two earthquakes struck in one of the worst possible places for that to happen. The epicenters sat only about 150 kilometers west of Caracas, the Venezuelan capital, a metropolitan area that is home to millions of people. They were even closer to the major cities of Valencia and Maracay, two of the most populous urban centers in the country. This was not a remote rupture out in the ocean or beneath an empty desert. This was a pair of major earthquakes going off in the middle of one of the most heavily populated regions in all of South America. The United States Geological Survey responded by assigning both earthquakes its highest impact tier, a red alert on the system it calls pager. A red pager alert is not issued lightly. It is reserved for events where the agency's models expect mass casualties and major economic loss, the kind of disaster that reshapes a country. 2 red alerts for 2 earthquakes, in the same 40-second window in the same place. In the first hours of Wednesday night, it looked like a catastrophe of historic scale was unfolding. Images of collapsed multi-story buildings spread quickly, and early observers feared a death toll that could climb into the thousands. The combination of 2 major, shallow earthquakes near 3 large cities pointed toward exactly that kind of outcome. By the following morning, a more complicated picture had emerged. The human cost was serious, and the figures were still preliminary, still expected to change as rescue crews reached the hardest-hit structures. But the early fears of a death toll in the thousands had not, at least by that point, been realized. The outcome was meaningfully better than those first scenes had suggested. That gap between what the data said should have happened and what was actually reported is one of the things investigators will be studying for a long time. But to understand why these earthquakes happened at all, you have to look at the fault underneath them. Northern Venezuela sits along the boundary between 2 of the planet's great tectonic plates, the Caribbean plate to the north and the South American plate to the south. These 2 plates are not colliding head-on. They are grinding past each other sideways in what geologists call a strike-slip motion, along a family of faults with names like the San Sebastian and the El Pilar. These faults run roughly east to west across the top of the country, and they have been locked in loading stress for a very long time. This is the same general fault system responsible for one of the deadliest natural disasters in Venezuelan history. In the year 1812, a catastrophic earthquake struck this same region, devastating Caracas, and killing a substantial fraction of its population at the time. The faults that broke on Wednesday night are part of that same dangerous family. In other words, this region was always going to do this again. The only questions were when and how violently. The fact that the rupture was strike-slip, sideways motion rather than vertical, also explains something important about what did not happen. No tsunami was generated. The tsunami warning systems recorded a flag of 0 for these events, because a sideways rupture on land does not lift a column of ocean water the way a vertical thrust under the seafloor does. The danger here was never the sea. It was the shaking itself and the buildings standing on top of it. The single strangest fact of Wednesday night is the doublet itself. Two major earthquakes, magnitude 7.2 and 7.5, less than a minute apart. How does that happen? The mainstream explanation is both elegant and, frankly, a little unnerving. It is called earthquake-to-earthquake triggering, or stress transfer. When the first fault segment ruptured, it did not simply release its stored energy and stop. It redistributed that stress onto the neighboring segment of the fault. And if that neighbor was already loaded close to its own breaking point, the sudden jolt from the first rupture can be the final push that sends it over the edge. The second earthquake, in effect, was triggered by the first, almost instantly. This is a well-documented and physically understood phenomenon. It does not require any exotic cause. It does not require anything from outside the Earth. It simply requires two neighboring fault segments that were both close to failure, where the breaking of one pulls the trigger on the other. The 40-second gap between the two Venezuela earthquakes is, in fact, far better explained by this near-instant stress transfer than by any external force you could propose. And that point is going to matter enormously in a few minutes, because there is another part of this story, a part that has nothing to do with the ground at all. While northern Venezuela was breaking apart, something was happening 93 million miles away that has a certain corner of the internet absolutely convinced that the two events are connected. Before we leave the earthquake itself, it is worth sitting with what a red pager alert actually means on the ground, because the numbers can make it abstract. A magnitude 7.5 earthquake releases an enormous amount of energy. And when it does so, just 10 kilometers beneath a region full of cities, the result is violent, sustained shaking across a wide area. Older buildings, structures that were never engineered for this kind of force, are the most vulnerable. That is what produced the images of collapsed multi-story buildings that circulated on Wednesday night. A short time after the two main shocks, at roughly 23 minutes past the hour, an aftershock of magnitude 4.5 struck nearby. A reminder that a fault system this size does not simply go quiet after it ruptures. Aftershocks are not a sign that the danger is escalating. They are the fault settling into its new configuration, and they will continue for days and weeks. But each one is a fresh hazard for structures already weakened by the main event. The reason the final toll appears to have come in below the worst early projections is something disaster scientists will analyze carefully. It may come down to the exact timing, the specific construction in the hardest hit towns, the precise way the energy radiated. What is clear is that a region sitting on a mature, heavily loaded strike-slip boundary just demonstrated in the most direct way possible how little warning these faults give before they fail. And it did so at almost the exact moment that the sun was doing something of its own. Here is where this story stopped being a regional tragedy and turned into a global talking point. In the same window that the ground was moving across northern Venezuela, the earth was being washed over by a stream of fast solar wind flowing out of a large coronal hole on the sun. A coronal hole is a region in the sun's atmosphere where the magnetic field opens up and lets solar wind escape at high speed. When that high-speed stream reaches Earth, it can pile into our magnetic field and stir up a geomagnetic storm. And on Wednesday, the timing was almost theatrical. The solar wind speed, which had been sitting around 350 kilometers per second the day before, climbed to about 450 and then accelerated sharply beginning around 5 in the afternoon, universal time, reaching roughly 600 kilometers per second, with plasma speeds near 700 kilometers per second pushing into the following morning. The speed of the solar wind, in effect, roughly doubled. The orientation of the magnetic field carried by that solar wind turned southward, with a key measurement swinging to between -5 and -11 nanotesla. That southward turn is what allows solar wind energy to couple efficiently into the Earth's magnetic field. The result was a geomagnetic storm, a minor one, what forecasters classify as a G1, with the planetary activity index reaching 5 and peaking in the early hours of the following morning. Space weather forecasters issued storm warnings overnight. To be clear about scale, a G1 is the mildest category of geomagnetic storm. On a normal day, its most visible effect is pushing the northern lights a little farther south than usual and causing minor fluctuations in power grids that operators routinely manage. By the middle of the following day, the solar wind had already eased back to around 450 kilometers per second, and conditions were settling toward quiet. This was not a historic space weather event. It was a common, run-of-the-mill disturbance of the kind the Earth experiences many times a year. And that ordinariness is going to be central to the question everyone started asking that night. Now line up the clocks. The solar wind sharply escalated starting around 5 in the afternoon, universal time. The cluster of major earthquakes hit in the 10 o'clock hour that same evening. To a body of fringe to speculative thinking that argues the sun can trigger earthquakes, this overlap reads like a confession. So let us take that idea seriously, and then let us look at what the data actually says. The claim that solar activity can trigger earthquakes is not pure invention. There's a real, published, and genuinely contested body of scientific literature that has looked for statistical links between solar and geomagnetic activity in the timing of earthquakes. The proposed mechanisms get fairly creative. Some researchers have suggested that the rapidly changing magnetic fields during a solar storm could induce electrical currents in the conductive rock of the crust, subtly nudging the stress or the fluid behavior along a fault that is already near failure. Others point to coupling between the upper atmosphere and the ground, the idea that disturbances high in the ionosphere during a solar wind surge transfer a small additional load down to the surface. There are even proposals involving tiny solar-driven changes to the speed of the Earth's rotation. A widely followed online commentator who specializes in this kind of material presented Wednesday's earthquake cluster as confirmation, an astrogeological smoking gun pointing directly at the overlap between the solar wind surge and the 3 large quakes that struck within hours of it. Here is the most honest version of this hypothesis, the version that a careful scientist would actually defend. At most, the sun could act as a small final trigger for an earthquake that was already imminent, not a cause that creates earthquakes out of nothing. The fault still has to be loaded to its breaking point by tectonic forces over decades or centuries. The sun, in this framing, would only ever be the final straw, never the weight. And that distinction is everything, because it sets up the question that actually decides this. Even if the sun can be a straw, was it the straw on Wednesday night? For that, you have to look at the numbers. The case against a solar trigger on Wednesday is strong, and it comes down to coincidence math. Large earthquakes happen somewhere on Earth every few weeks. The planet averages on the order of 15 magnitude 7 earthquakes every single year, and well over 100 magnitude 6 events. At the same time, enhanced solar wind conditions are not rare either. Coronal holes recur roughly every 27 days, in step with the sun's rotation, sending high-speed streams toward Earth again and again. When you have two things that both happen frequently, they're going to overlap by pure chance on a regular basis. To prove that the sun is actually triggering quakes, you would have to show that earthquakes happen during solar disturbances more often than chance alone predicts, across enormous catalogs of data. The published attempts to demonstrate exactly that remain statistically weak and disputed. But the strongest argument against a common solar cause is not statistical at all. It is tectonic, and it is sitting right there in Wednesday's own data. The Venezuela earthquakes were strike-slip ruptures, 2 plates grinding sideways past each other. The major earthquake that struck off the coast of Japan that same evening, which we will get to in a moment, was a completely different beast, a subduction zone rupture where one plate dives beneath another. These are 2 fundamentally different fault mechanisms, on opposite sides of the planet. For a single external trigger to reach down and set off both of them within 25 minutes, while somehow leaving untouched the thousands of other faults around the world that are also sitting near failure, is extraordinarily difficult to defend physically. A real trigger would not be that selective. So the grounded reading is this. Northern Venezuela sat on a mature, overloaded fault that was overdue to fail, and when it failed twice in seconds because one rupture triggered its neighbor. The solar storm was real, but it was ordinary space weather, and its overlap with the earthquakes was a coincidence. A genuinely unsettling coincidence, but a coincidence. And the reason that coincidence felt so compelling has everything to do with the rest of what the planet did that night. Wednesday was not just Venezuela. It was, by any measure, an unusually violent day for the entire planet. Earlier that same day, at 10 minutes past 3 in the afternoon, Universal Time, a magnitude 5.5 earthquake struck Northern California near Redwood Valley in the Mendocino region, along the northern reaches of the San Andreas Fault System. Then came Venezuela in the 10 o'clock hour. And then, just about 25 minutes after the Venezuela doublet, a magnitude 6.9 earthquake struck off the east coast of Japan near the city of Kuji on the island of Honshu. That Japanese earthquake was a subduction zone event, where the Pacific Plate is diving beneath northern Honshu along the Japan Trench. It was centered roughly 50 kilometers below the surface, far enough below the seafloor and offshore enough to prompt a tsunami warning for the area near the east coast of Honshu. And it was followed the next day by an aftershock in the magnitude 4.8 to 5.0 range. The California earthquake earlier in the day, the magnitude 5.5 near Redwood Valley, came from yet another system entirely, the network of faults associated with the San Andreas in Northern California, at a depth of about 9 kilometers. So within a single evening, 3 significant earthquakes struck 3 widely separated regions, on 3 different continents, driven by 3 different fault systems. The 2 largest, Venezuela and Japan, hit within about 25 minutes of each other on nearly opposite sides of the world. You can understand why. Watching this unfold in real time, it felt like the entire planet was ringing like a bell. But the global baseline tells the sober story. With roughly 15 magnitude 7 earthquakes and more than 100 magnitude 6 events scattered across an average year, multiple large quakes on the same day is statistically uncommon, but genuinely not unheard of. Over the 7-day window surrounding these events, the global catalog logged about 103 earthquakes of magnitude, 4.5 or greater, which is well within the normal range. The planet was not behaving abnormally. It was behaving like the planet on a day when the dice happened to come up loud. And the very fact that those 3 quakes came from 3 unrelated fault systems is the same reason a single solar trigger does not hold up. They had nothing in common except the calendar. Here is the part of this story that genuinely deserves your attention going forward, and it is not the connection between Wednesday's storm and Wednesday's quakes. It is what the sun is about to do next. A large active region, a sunspot group designated 4478, has been rotating into view on the sun's eastern edge. This is not a quiet region. It covers an area of roughly 500 millionths of the solar disk, contains around 20 individual spots, and carries the magnetic classification that scientists label beta gamma delta. That classification is the important part. A delta configuration means magnetic fields of opposite polarity are packed tightly together in a tense, tangled arrangement, and it is precisely the setup most capable of producing major solar flares. The modeled odds for this region tell the story. Forecasters put the chance of a smaller C-class flare at around 95%, an M-class flare at roughly 45%, and a major X-class flare at about 10%. It is worth being concrete about what those odds actually threaten. A major X-class flare can cause radio blackouts on the daylight side of the Earth within minutes, and if it launches a coronal mass ejection aimed at us, that cloud of charged particles can arrive a day or two later and drive a far stronger geomagnetic storm than the minor one we just experienced. That is the kind of event that can stress power grids, disrupt satellite operations, and interfere with navigation and communication systems. None of that is speculative. It is the well-understood consequence of a flare-capable region pointed directly at Earth. Right now, that region is still near the edge of the sun, which means its measurements carry some uncertainty and its energy is not pointed at us. But that is changing fast. As this weekend ends and the coming days unfold, Sunspot Region 4478 is expected to rotate to face Earth directly. And when a magnetically complex flare-capable region turns to face us head-on, the odds of an Earth-directed flare, or even an Earth-directed coronal mass ejection, climb significantly. That is a documented forecastable risk, and it is a far more concrete reason for concern than any unproven link to Wednesday's earthquakes. So where does this leave us? In the immediate term, the situation in northern Venezuela is still developing. Aftershocks will continue along the San Sebastian and El Pilar fault system for days and weeks, each one a renewed hazard to buildings already damaged by the main shocks. The casualty figures are preliminary and will be revised. And seismologists will be studying this doublet for years because 2 near-equal major earthquakes 40 seconds apart is exactly the kind of event that sharpens our understanding of how faults transfer stress to their neighbors. The honest verdict on the bigger question is that the sun almost certainly did not pull the trigger on Wednesday night. The solar storm was real, the timing was eerie, but the physics points to coincidence and the tectonic evidence points away from any common cause. The legitimately unsettling part of this story was never the sun. It is what northern Venezuela just demonstrated about how violently a shallow fault near major cities can move, with essentially no warning, on a boundary that looked quiet right up until the moment it broke. And the forward-looking concern is real, just pointed in a different direction than the headlines suggested. Keep your eye on Sunspot Region 4478 as it swings toward Earth in the coming days. Watch the aftershock sequence in Venezuela. And remember the lesson the ground delivered on Wednesday night, which is that the faults beneath the world's dense cities can fail this catastrophically at any time. And they do not check the space weather forecast before they do. We will be tracking all of it as it develops.